Hello and welcome to Snapshot. I'm your host, Alan Wolfe, and on this edition of Snapshot, we are going to take you behind the scenes here at the National Hurricane Center. Our tour guide and host today will be the director of the National Hurricane Center, Dr. Bob Sheets. So sit back, relax, and enjoy. We're here with Dr. Bob Sheets at the National Hurricane Center, and I've always wondered, besides hurricane work, what do you do here?
Well, most people think of us in terms of hurricanes. That's the one that's sort of the one that gets us the most publicity. But actually, this organization has year-round responsibilities almost from Africa, almost all the way to Hawaii, from the equator up through about 32 degrees north. And so that includes all the Caribbean Sea, all the Atlantic Ocean, basically in the tropical, subtropical region, the Gulf of Mexico, and the Eastern Pacific. In those areas, we have forecast responsibilities for high seas, so all ocean-going vessels, anybody that goes out on a cruise ship out of the Miami port or any other port that going into the Caribbean, Gulf of Mexico, or Atlantic, or into the Eastern Pacific, they rely on our forecast. Anybody flying from here to South America or Central America or down through the Caribbean, they also rely on our forecast and warnings. And then those people out on oil rigs on the Gulf of Mexico and some of the fishing fleet that are out there, they rely on our Gulf area forecast. And that's our unit right over here that actually does that work.
Let's go take a look.
One of the first things we need to do, of course, is to analyze what's going on in the tropics. That means
I recognize the United States and some of the Caribbean, but a lot of other stuff on here, no clue.
Well, you start over here from Africa. In other words, we're looking at the tropical and subtropical belt, starting from Africa, here South America here, Central America here, of course the Caribbean, and then out in the Eastern Pacific. So we have the responsibility essentially from Africa almost all the way to Hawaii. What we're seeing on here are surface observations. This happens to be a surface analysis, and so these mean ships that are out there. That means ships that are out there, and any kind of surface observations that may be available to us to analyze where are the high pressures, the low pressures, where are the tropical waves that are showing up in there, how moist is the atmosphere, how unstable is the atmosphere. And you see that on this screen over here. This is actually being done on the screen, and then the analyst will actually draw the contours that are on here, and then you print out this map like this and hand it out to the forecasters to analyze.
And what is the training required to be in this job where you deal with the maps and so on?
Well, everyone in our organization that does this kind of work has at least a Bachelor of Science degree in meteorology. Many of them have master's degrees, and some have PhDs.
And of course, this is a government agency, NOAA, and it's part of which department?
Well, NOAA, we start from the Department of Commerce, and then we have NOAA, the National Oceanic and Atmospheric Administration, and then the National Weather Service, and we're one of the national centers within the National Weather Service.
Well, certainly a lot more to see here at the National Hurricane Center. As we continue our tour of the National Hurricane Center with Dr. Bob Sheets, I see lots and lots more electronic equipment, stuff I certainly love. This is an interesting looking picture.
Well, we want to start with the aviation products first. In other words, that we have a lot of responsibility. Marine, aviation, and of course those for tropical cyclones, hurricanes, and all those forecasts and warnings. But let's just talk about aviation to start with. Right here, we have, of course, Florida's here, the Gulf of Mexico here, and then these little boxes that are drawn out there, those are areas that are controlled by the various FAA centers. For instance, this box here is controlled by the Center out of Miami, and this one over here is controlled by the Center out of Miami. This one is controlled by the Center out of San Juan, so you got that, and this one is controlled by the Center out of New York City.
You say control, we're talking about areas of responsibility?
Aircraft control. I'm talking about the FAA, and that's the areas of responsibility for the Miami Center, for the San Juan Center, and for the New York Center. And then over here is the Houston Center. Now, this office then is responsible for the forecast and warnings of severe weather in those particular areas, what we call SIGMETs that are issued. So if you have groups and clusters of thunderstorms that start to develop or potentially developing going into those areas, then we issue SIGMETs, and the FAA Center then will redirect some of the aircraft around it, advise the aircraft as to what may be developing in that area. So that's a 24-hour-a-day operation here, just issuing those SIGMETs. Then we have also a larger area of responsibility, which is sort of a general aviation forecast for that particular area. Again, here's the severe weather kind of warnings that take place relative to aviation.
Are we looking at a real-time display?
Right now, that's in real time. As a matter of fact, we have some other things on there that I'll show you. For instance, this is what we call our water vapor channel information, and so it's not just the thunderstorms you're seeing on here, but also the moisture in the atmosphere. You can see that from this special satellite imagery, and then superimposed on that, we have the various winds that may be encountered. So there may be turbulent conditions in addition to the severe weather that we associate with showers, thunderstorms, activity in that area.
How accurate are the outlines of where Florida is in the coast as far as, you know, the scale to the mile? Is it to the half mile?
No, it's not that accurate. The satellite, of course, wobbles a little bit right now because it's getting old and there's a little stability factors there. But it's pretty accurate. It's certainly accurate enough in terms of the warning process. We're not warning down to the specific mile, but within a particular grid point area that we're looking at.
Let's move on, Dr. Sheets. See what we have here.
Well, we've got to put that information that's in a graphical form there, a written form here, and the forecaster here, Chris Burr's been the one on the day, has been analyzing that and puts it into a numerical kind of product. It goes out an alphanumeric kind of product so that people who receive this across teletype systems or whatever, they don't have this imagery available to them, but then he interprets what's here, forecasts that, puts it together here, and analyzes what's going on in the atmosphere. So these are just here. This is what we call the satellite interpretive messages, based on what we see on the satellite, based on all the other data that's available there. Then this forecaster puts down what he thinks is happening with that meteorological condition at the time. Then we put out over here what we call our SIGMETs, our areas that I talked about earlier. Some of the SIGMETs that are there, that's significant meteorological events that aviation must be concerned about. Tropical weather discussions, a lot of users there. We not only have the aviation community that uses it directly, but the TV meteorologist who also uses these products to help interpret what's going on out there, the general characteristics of the atmosphere, what we saw on the surface analysis a little bit earlier than there, and then the ships at sea, the captain out there on the vessel who's getting that product, and so he needs to have those products interpreted for him because he doesn't have all of this satellite imagery and all the other things you're seeing behind us. And then behind here we have a view here of the entire hemisphere. So we're seeing here, again, this is the water vapor channel information. It's time-lapse form. In other words, it's displayed in time-lapse form. So we can see over here is Hurricane Celia going on right now. There are tropical waves that are moving across from Africa all the way across into the eastern Pacific. And so all those systems are being analyzed by our forecasters here and included in these analyses that go out.
And I can see, as a layman, I can see that it appears to be what is an eye here. Am I correct?
Yeah, in Hurricane Celia a little bit earlier, we had a well-formed eye. Then I hit the wrong button there, but we had a well-formed eye that actually was there yesterday. It's now weakening, so the system is not as strong as it was yesterday. But the kind of features you see on here are the tropical waves and all the weather that's associated with them, the trough of low pressure that created so much rainfall over Florida for the last few days in this area. And so we're able to see that included in our messages. Then we get up here to the Gulf of Mexico. We have some other forecast responsibilities in the Gulf of Mexico here because there are a lot of oil rigs up in this area. There are fishing vessels that actually go out in this area, and so we have to provide forecast and warnings for those individuals. And then you've got all of the area for high seas. So if you're on a cruise ship, leaving out of this area, going out into the Caribbean, going down to the Bahamas, going down into the eastern part of the Caribbean, going down to Central America, or in the Gulf, or in the Eastern Pacific, then those forecasts come from this office.
You know, I feel somewhat more protected just thinking about going out on a ship now, knowing that the Weather Service is involved so deeply in all of this. I had no idea.
Well, as I said, that most people think of us as the National Hurricane Center because that's the one that gets most of the publicity that people are aware of. But the user knows this is going on. In fact, this unit issued more than 7,000 products last year. So they go 24 hours a day, 365 days a year.
Well, let's move on. Where to next?
Well, we got other sections here of this particular unit. People at work.
Okay, as we move on, we find ourselves looking at some new display.
Well, this is what we call a tropical weather discussion that he's working on here. A meteorologist working on here trying to describe what's going on across the tropical Pacific. And right up here, for instance, he's got Hurricane Celia that you see spinning away here, but other features that are in the tropical Pacific, these tropical waves that move across, and maybe some potential for the next system to be forming in there. And so that goes into a message that goes out to ships at sea, as well as the others who may be using it. The Mexican government, meteorological services in Mexico, they're using that, and of course all the way out to our own offices in Honolulu, Hawaii.
Do these various governments outside of the U.S. have to subscribe to your service, or is it available over satellite, or how does that work?
Well, we are part of the United Nations World Meteorological Organization. The whole world is split up in sectors, and we are what's called the Regional Specialized Meteorological Center, and so we have the responsibility for this hemisphere. So we work with all the governments in North America, all of those in Central America, all of those throughout the Caribbean, the northern part of South America, and so we have the responsibility for issuing those products. We have the responsibility both, as I mentioned earlier, aviation and marine. So the world is split up. Various groups have those same kind of responsibilities around the world, but we have it for this hemisphere.
Very interesting. I notice, much like you see on television weather forecasts, I notice different colors there.
Right.
How about those?
What we try to do is we use what we call a little bit of enhancement. It's really false colors that are used using the computer and digital data that's in there to try to highlight deep convection, big thunderstorm activity. You see that going way up here, and you see some reds and yellows that are in there. Now, what it's showing over here, Hurricane Celia is weakening. If you've seen this yesterday, it had a lot of reds and yellows and had the eye of the hurricane very well formed there, and certainly on Saturday very well formed. But now it's moving over a little cooler water, and that's what he'll be describing there in the tropical weather discussion, that's moving over cooler water, and so it's weakening a little bit. And then over here, looking here, here's an area of convective activity, shower thunderstorm activity, some yellows, not some reds, but we look at all of those in a time-lapse form and watch those systems develop or weaken. And that's what goes out in this alphanumeric product that, again, can go to anyone who receives our products.
Well, the activity just never stops here at the Hurricane Center.
Fires come from?
Well, what we have here is where we're zeroing in, focusing in on the hurricane activity, tropical cyclone activity. And so the forecaster and meteorologist here, what he's doing is analyzing what's going on with that particular storm. This happens to be Celia that he's looking at right now. And so we've got to locate it. Where's it located right now? How's it been moving over the past few hours? And then make some estimate of the intensity of that storm based on the satellite imagery. If we get a storm, which we also have reconnaissance aircraft in there, so we'll compare the aircraft measurements with the satellite-based estimates.
Now, when he does the analyzation, we're talking about a subjective kind of a visual thing based on his training and previous experience and so on?
There is subjectivity there. There are certain objective measurements that are made. For instance, how cold are the cloud tops? So that tells you how deep the system is in the atmosphere. How large does the cold area cover? What area does it cover? How well organized is it? Is it circular? Is it elongated? And all those kind of things that are done in an empirical study to try to relate what the intensity is. So there are actual measurements that are made there, and then some subjectivity in the application of that technique to come up with the number that indicates the intensity of that particular storm.
And on we go.
Okay, what we have here is what we're putting together, what we call our satellite interpretive messages. So looking at all the features that you may be able to see on the satellite and trying to put that into what we call an alphanumeric product that will go out to all of the users. So he's talking about the synoptic features there. He's got it's abbreviated kind of form there. Upper level anticyclone over Mexico continues to dominate the weather over here in the Gulf Coast area, for instance. You're seeing some of the features there. Over here's the Hurricane Celia, and some of the tropical waves that are there. So it goes through that, puts it together into an alphanumeric product. That goes out to all of the ships that are out in this area, or all the TV meteorologists, or all the private firms, meteorological firms that may be using those products. And so we have an interpretation of what's going on in that satellite imagery, because not very many people have this kind of product available to them.
And these go out by radio and by hardline, telephone line?
Teletype systems, yes. On teletype systems, some places they end up getting fax, some places they get into computer networks. So it all depends on what the particular user has available to him. Essentially goes out to the world in this product.
Well, we're in the hurricane forecast area now, the forecasting area. Is it an absolute science, or what's the situation now on the ability to forecast these things?
Well, it's certainly science. It's not absolute, that fact that we don't have perfect forecast in terms of where a storm's going to be and exactly where it's going to go. But certainly it's very much related with the scientific background, the computer outputs as to what the numerical models indicate as far as the atmosphere is concerned, how it's going to steer this hurricane or modify this hurricane or cause it to weaken or strengthen or whatever that is. Right now we're working on Hurricane Celia out here in the eastern Pacific, and that's moving away from land. But let's take a hypothetical storm to give you some idea how the whole forecast and warning process works. Let's assume we have something that's coming into the Caribbean. Now we have our regional responsibilities under the United Nations, where we are the responsible agency for all of Central America, all of North America, all of the Caribbean islands. And so we coordinate all of our warnings throughout that region. And we have, under the World Meteorological Organization, we have a line that we pick up here, and so we can talk to those countries down through the Caribbean, the islands down through the Caribbean. So let's take Hurricane Hugo, for instance. It was heading into the eastern Caribbean. It was threatening Guadeloupe. It was threatening the Dominican Republic. It was threatening Puerto Rico, the U.S. Virgin Islands, the British Virgin Islands, Dominica, and so on. Well, Barbados has a responsibility for Dominica. Dominican Republic, of course, has their own responsibility. Puerto Rico, the U.S. Virgin Islands, that's our office in San Juan, the National Weather Service office in San Juan. The British Caribbean, basically up into the British West Indies, as we get up into that area, British Virgin Islands. Then you have Barbuda and Antigua and so on there. And then the French islands, Guadeloupe and Martinique. And so we'll talk to them here on our special line. We have a restricted line, so we'll talk to the meteorological services there. We'll coordinate our warnings, and we'll put that together and put out our product from that. Now let's assume it was going to be something that might affect the state of Florida, for instance. First of all, we do the meteorological coordination, and that's this phone right here. In this phone...
It's the hurricane hotline, it says.
The hurricane hotline, exactly right. It's a 2-digit dial. And so what we would do here is we'd call up the National Meteorological Center in Washington, our own forecaster here who's done the forecast, what we think the storm is going to do. Independently, we have a forecaster in Washington at the National Meteorological Center who also initiates some track that they think that the storm may follow. And then we have our forecast offices along the coast. And so we put them on here, and then we do the coordination with this. So we put out our forecast in terms of the meteorology and hydrology. What areas are going to be impacted by this hurricane? Specifically, where is it going to go? How strong is the wind field going to be? What areas are going to be inundated by the storm surge as the storm comes ashore? And so we do that, go through this coordination process internally.
Now, I may be wrong about this, but it would seem to me that you have to be ready to put out a hurricane watch warning or whatever, but at the same time, this costs lots of money if you're wrong, and if you're right, you're a hero, and if you're wrong, you're not a hero.
Well, it certainly costs a lot of money and could cost a lot of lives. So you're always weighing the cost versus the impact of that particular hurricane. So you have a very narrow line that you walk. You don't want to overwarn. any more than you just absolutely have to, because a hurricane warning is a $50 million decision, whether the storm ever strikes or not. That's what it costs on average to prepare the continental United States coastline for an average warning, is about $50 million. If it includes major metropolitan areas like Southeast Florida, the numbers are far larger than that. But if it includes New Orleans, the numbers are larger than that. But the average coastal area is about a $50 million decision. Now, you can't keep warning and never have the event strike, or people won't respond. So then it's a potential loss of life with a lack of response. So it's not that one individual sits down here and says, okay, I think the storm is going to do this. But there's a lot of numerical guidance. Right here behind us, we have some of the numerical guidance that is going into this Hurricane Celia.
I see
that.
that.
Actually had it plotted out there. This is the actual track. And then several of the models. Here are some of the models that indicated where the storm was going to go. So there's several models that go into that.
So do I understand correctly that these forecasts are based on a consensus of various people up and down the affected area, as well as your people here?
Well, consensus is not the right word. The responsibility is here. Basically, we get guidance from other people. We may think that what's going on is going to happen like this. Somebody else may see something slightly different and maybe influence what we think may happen with that particular storm. So there's a little bit of guidance that takes place. But no, the forecast responsibility is right here. So it's not a consensus of opinion. Our people who are the experts, they had 20, 30 years experience in this area. And so we take all of those factors into consideration. So we do the National Weather Service coordination. That's the internal coordination that takes place there. The next step is now with the state and local emergency management. So those are the people who are going to have to decide what response is going to take place for this particular hurricane. Are we going to evacuate a particular area? And so this red hotline, this is, and I have to hold the button down because it's literally hot if I pick that up, we can talk to Tallahassee or any one of the emergency management offices around the state, or all simultaneously. So if it's going to affect the state of Florida, we'll say plug in Dade County, Broward County, Palm Beach County, Monroe County, etc., and the state coordination center in there. And so we can talk to everybody there simultaneously, and we'll talk about, here's what we're forecasting, here's what we're expecting, and they may come back with some questions as to what we think the timing will be, or what recommendations we would have in terms of areas that might need to be responding to that hurricane. If it's national, if it's Carolinas, for instance, and Georgia and so on, then this is the hurricane hotline. This is the what we call the old NAWAS system, the old nuclear attack system. So it's hot. We pick that up, Washington picks it up, and we'll say plug in the state of North Carolina, Virginia, South Carolina, etc., so we can do that same thing.
And that's all instant.
That's essentially done instant. This one here is absolutely instant. That one is a system where the central control facility there will do a 10-minute kind of dial-up or something like that. We'll say 15 minutes before we plan to do the briefing, is that we'll say get everybody on the line, then they'll get back to us 15 minutes from now, and so everybody's on.
So these evacuation decisions do not come from here, but rather from these emergency operations centers based on the information, the best information that you've given them.
That's exactly right. The responsibility for response lies with the state and local governments, emergency management at the state and local government level. And so that coordination takes place. It wouldn't do well to, say, evacuate the Florida Keys and Broward County, but not Dade County. So that doesn't look too good in the sense of, it just doesn't make a whole lot of sense. And as you look up and down the coast, the same thing is the same kind of problems. Or the response through the Caribbean islands is to have two with warnings up on either side of one without a warning, for instance. And so the coordination is a big factor. And the coordination in terms of response and evacuation is a big factor. And so it's an exercise that we go through in the non-hurricane season to make sure the whole system works. People go through those kind of exercises, and we go through those drills to make sure we're ready. And then when the real event comes along, then it works smoothly.
Dr. Sheets, in terms of forecasting hurricanes, has it gotten better? Has it gotten worse? And if so, why or why not?
Yes, we are improving. There's no question about it. Our forecasts are substantially better today than they were 2 decades ago, and they're getting better. But the problem is that our population in the coastal areas that are at risk to the hurricane is increasing at a far faster rate than our ability to forecast where the storm is going to go. So in the 1940s and 50s, when we had hurricanes striking Florida, and we had a lot of them back in the late 40s striking Florida, if we provided 6 hours of lead time for people to respond to the hurricane, or 8 hours, that was sufficient. Today, we have to provide 24 hours, and maybe even a little bit longer than that in the Florida Keys, maybe as much as 30 to 36 hours of lead time. So that's the big problem. There's just the fact that our population is increasing so fast that it makes it much more difficult to provide sufficient warning to protect those lives and property.
What is the biggest danger to human life during one of these hurricanes?
Well, in terms of the large loss of life, it's always due to the water. That's the rising water of the storm surge right along the immediate coast. The whole ocean will rise. In Hurricane Hugo in South Carolina, the whole ocean rose 20 feet. So you can imagine something about 3 times my height here almost, 3 times my height, that those hurricanes would come along and the water would rise that much with waves on top of that.
So people need to evacuate if they're told to do so.
Right. Barrier Island, certainly the Florida Keys, you can imagine what would happen there if the island is cut off and people are in their cars trying to get out at the time the water is now crossing the road, just as it was in the 35 hurricane when the railroad, the train was swept off the railroad track and we lost hundreds of lives down there. So my fear today is if we have large loss of life, it's probably going to be those people coming out of the Florida Keys where they've tried to get out too late and now they're in their vehicles at the time that the water crosses the road.
So your message to the public would be real short and simple.
Simply, when the hurricane warnings go up and the local officials say it's time to evacuate, even when the sky is blue and the sun is shining, it's time to evacuate.
Well, we're getting a bird's eye view, Dr. Sheets. From how high? I guess this bird would need oxygen.
Well, yes, it's up at 23,000 miles, and that's what we call geostationary satellites. That means that it's up at the point where it stays just above the same point on the Earth. It rotates with the Earth, and that's how we're able to put those pictures in time-lapse form.
And
now,
what are we looking at here?
Well, right now we're looking at Hurricane Cia. This is Hurricane Cia. You'll see the eye show up here right there. Now it's weakening a little bit, so the eye fills a little bit, but it's moving toward the west out in the eastern Pacific right now. We talked about earlier about the forecast and warning process where we went from the meteorologist, then the emergency management for the response, and then we go to the public. And this is how we go to the public to be able to communicate directly as to what we think this hurricane is going to do.
And this essentially is why when we see the commercial television meteorologists, they all have about the same story.
Yes, we hope so, because indeed that if you don't have that, if you're not together in some way, then you have a confusing element that goes in there, and people may respond in the wrong way or not respond at all. And so we may have people stuck in the Keys who should have gotten out when the sun was shining and the sky was blue. So that's one of the problems that we have in some areas. Most of the time, the great majority of the time, we work very closely with all of the TV meteorologists. It's a real team effort to make sure people respond in the right way.
Well, Dr. Bob Sheets, thank you so much for joining us on Snapshot and giving us this wonderful tour of the National Hurricane Center. It has been our pleasure.
It's been my pleasure.